Dear students, so today I will explain for you that how the ARFF file looks like and what are the explanation for each steps. So this is the sample, one of the sample for Weka file, and we can see that what are the ingredients in it. So if you look at this file, what we have, these are like comments, and these are like prerequisite, and it doesn't have impact on the file of the data. So since this is a semi-structured data or semi-structured data, and we will see that how the information looks like. So all this with the this person side, these are like meaningless for us, and it doesn't have any contribution for the R file. So basically the R file starts with the at the rate of relation, and this is a relation means the table name. So as in Oracle we have a table name, like we say that create table name, and then we start with the column names and define each column name, whether it's a real value or it's a floating value or it's a integer value or varchar 2 value. So similarly we also define here that what is the relation, what is the name of the relation. And you should keep in mind one thing, that whenever you whatever the name you write here, it must be same as the name of the file here. So see, you can see iris.arff. This is important. If it doesn't match, so the Weka will not pick this file. So you can see over here, this is the iris file. Now the names of the columns. So how can we define the name of the column? So this is the table for a flower, different characteristics about the sepal and petal, length and width. So you can see the first attribute means the first column is sepal length, and we can write the sepal length. And what is the value? So the value is real. Real means floating value. So you can see here the first value is 5.1. So this must be respective value. So in the data section, you need to keep the data accordingly with respect to the first attribute. Data must be here, kept here. Then we have a second attribute, and the second attribute is sepal width, and it's a real value as well. So, and the data we can keep here as well. You can see over 3.5, which is also a real value. Then in the third one, we have a petal length. Okay, so petal is different and sepal is different in a flower. The green color, that is called sepal, and the red color is called the petal in a rose flower. And this one is attribute petal width is real. Real means this real number. So we have like these four values entries into the data section. And the last one is a class one. So class is important. You need to define how many classes are there. So here we have like three different classification. Like for example, the flower could be either Iris setosa, the flower could be either Iris versicolor, the flower could be Iris virginica. So these are three possibilities that according to the sepal length, sepal width, and the petal length and petal width, we could determine, or even the algorithm can determine whether it's a Iris setosa or Iris versicolor or Iris virginica. Now we come to the data section. So third section is data, and we can compute as much as data. The more the data we have it, the more will be the accurate will be your result. You can see over here the first section about iris setosa here, and the second one is this is about where is the color, okay, and the third one is about virginica. You can see over here. So this is like the one of the sample for this one. Now let's see some other samples we have it. Let's suppose we have some medical data. Let's suppose this is like the data for diabetes. You can see, so here you can see this is like this person sign. This is just like information for the user, but our real story begins with this one. So you can see over here the name of the relation is PIMA diabetes. We have it. Then we have attribute. This is PREG, which is a real one. Then we have a plus. Then we have a press. We have a skin. We have insulin. We have a mass. We have a pet, and these all are real. And classification is either the person or any patient who has a negative diabetes, or he has a positive diabetes, right? So based on these conditions, like for example, the first condition is PREG. So we can see what is the PREG. So most probably this is for like ladies. So we can see what are the what is the data. So after reading all this one, yes, yeah, so the first attribute is about the number of times they're pregnant, right? Second is the plasma glucose concentration for 2 hours in the oral glucose, this one. Third one is called diastolic blood pressure. The fourth one is a tricep skin fold thickness. The fifth one is a 2 hour serum insulin. Sixth one is body mass index. The seventh one is the diabetes pedigree function. And eighth is the age, right? And the ninth is the class, right? So accordingly, you can see over here. Now, if you look at this data, we can now analyze it properly that these are all the attributes we have it. So the first is the relation name. As I told you, the relation name must be same as the Arff table. Okay, the Arff table, this must be same. Okay, so this is like data, and then so there are in the classification we have two classes, either positive or negative, or just like in Corona COVID-19, we say it's a positive or negative. But in Corona the symptoms are different, so they are mostly related to the lungs, lungs classification, the whiteness in the lungs and non-whiteness in the lungs. So this is a medical data. Let's try some third kind of data. We have it. Let's suppose a marketing data. Okay. In supermarket, what kind of data we have it? I hope it opens. Yeah. So in the marketing data, you can see over here. Now this is very straightforward. There is no extra information about that one, so it's very clear. So the relation name is supermarket, so you can just double check with the name of this Arff table. So the extension is .arff. It is same like .xml. It is same like .json, but the structure is a bit different. So for Weka, you must store the data in the Arff file. Okay, now see, it has a lot of attributes. You can see over here plenty of attributes. You will be amazed to see sometimes a lot of attributes are good, but sometimes many attributes it cause like we need to select some of the attributes because it doesn't give you more accuracy or precision level. Yeah, so sometimes we need to be very selective in the attributes. So you see over here, this is the last yeah. So the class, so what is the class here? So in the class we have total, and that's low and high. Okay, and the comment is low means if it is less than 100, that is low. If it is greater than 100, it is high. So we will see that what does it mean low and high. So let's analyze one. The first thing is like department one. Okay, this is department one, and then we have the data related to department 2, 3, 4, and then you have a grocery because it's a market data. So we'll talk about the grocery things like baby needs. We have a bread and cake needs, right? And then we have a baking items. We have a coupons. We have a juice and start one. We have about the tea, biscuits, right? So you can see a lot of marketing data, because usually in market they have a lot of data over here, and you can see that how it variates. And then in the bracket you can see the options like T options, like T could be for availability or for true. So I hope so that is the case. And moreover, if you analyze over here, some data are missing. You can see there is no data, there's some, yeah, so the data is in a different format, or the data is missing. Yeah, some are available, some is not available, and some according to someone we can decide low. So the degree, the last part is like high and low, high and low. So if it is less than 100, so we call it low, and if it is greater than 100, we call it higher. So based on the given data. Now let's try some, yeah, some spam data sets for the spam in computer, because when we say the email is spam or is a real one, for that one, so we have two options, ham or spam. Ham is like okay, and spam is means the email is not correct. It might be from the malicious computers, or from the computers which has some virus in the attachment. So attribute, there's only one attribute, that's called text. So in the text is what text means. You just receive a text data, and usually the email is a text data, right? So you just have one attribute, and then based on this attribute you decide. And what is the name of the relation? So the name of the relation is SMS spam dataset Weka. This is the name of the relation. Okay, now you see over here what is the data inside. So the first data is the email. Okay, this is the This is very interesting. It looks like more unstructured data, as we told that the unstructured data is a kind of a text data, but we are like putting the unstructured data inside the semi-structured data or semi-structured data, right? So for example, they say go until the jury point crazy available only in the bogus great world buffet scene, there is a god. So this is like, this email looks like okay, so we call as a ham has been good. Okay, this one is okay, like joking with uni. Okay, so this one also look like a ham. Okay, now see spam. Okay, now see this one. Now this is a spam one. Okay, you can see over here free entry into a weekly camp in the World Cup final tickets, and takes this one. So this one is like, there is some code or some like number, so it looks like a spam. Other one is like this, also looks like a spam, right? Okay, and it could be a spam. So you already know about this one, this target data. And after this one, so you have a lot of good database. So it's good for training if you want to train your algorithm. So you can easily train your algorithm and can get to a result. Okay, so this is what you have it. Okay, so we have a lot of ham and spam and see. So for practice, I would recommend that you go for this one. Yeah. Okay, so this is like example. So I hope that things will be more clear to you. And okay, the last thing, if you want to save it, so there is a one tip that if you want to save this data on the desktop, so you must like, save, and just better to put double quotes. If you don't put the double quotes, it's a high probability that it will not be saved in a proper Weka format. So if you look at this one, it will be in a proper Weka format, right? So this is one of it will be usable now. Otherwise, it will not work. So thank you very much and see you in the next video.